What is up, Flutter devs? Today we're going to try to refactor and pull out the core raster and painting capabilities in Flutter Processing so that we can begin to simplify the structure of the overall code, which will hopefully allow some of you to come in and make some additions and bug fixes over time, and we can have more of a community involvement in this project. So let's jump in and see what we're going to do. Here we are in the code. I have the core file opened up here. And I haven't really worked through how all of this is going to be simplified yet. We're just going to go down a direction and see what happens. Most of everything that we've implemented is about painting pixels. So there is some kind of bitmap area. We paint it either with the canvas or with direct pixel changes, and then we produce a final bitmap, which is then drawn to the screen. Which means that, you know, the keyboard input, the touch input, the mouse input, that's not really the focus of most of these APIs, which means that I think if we're going to simplify things, we should focus on the bitmap part and see how simple we can make that, or how well we can divide up the different groups of methods based around the bitmap manipulation. Again, I don't know what the final solution is going to look like in terms of, do we use mix-ins or composition or inheritance, or what's the exact set of tools we're going to use to simplify this? But I think where it makes sense to begin is to pull out everything needed to essentially render a single frame of pixels. For example, here in the code that's on screen, we have a few properties. We have a picture recorder. We have an intermediate bitmap. We have access to pixel data in that bitmap. We have this flag that tracks whether or not we've done things to the canvas that were not captured in the intermediate image, and then we have the published image. These pieces of the puzzle are going to be relevant to every single frame that we paint, no matter what we paint. And so there's this, what I'm thinking of is something like a painting context. The absolute core pieces of functionality that any possible painting method needs. Everything will need what we just listed here, but also everything that's painting, or almost every method that's painting, needs access to a canvas. So a canvas also belongs in that painting context. I don't know if it's going to work out, but we're going to try to create that painting context here today. Things are going to get a little messier before they start to get cleaner, but that's where we're going to begin. So I'm going to come over here into the source directory, and I'm going to create a new file called painting context. Then I'm going to create a class called, I guess we can name this the SketchPaintingContext. For now, this is not going to be a mix-in. Maybe it will be at some point, but for now, I just want an object that I can instantiate to replace all of these same pieces within the sketch. Let's start moving stuff over and see what breaks. I'll take all of these properties here and cut them out and move them over into the sketch painting context. And let's see, if I close that, can you still see everything? Should be good. I guess this text is a little small, but I don't remember what the shortcut is to make it larger, so hopefully that's good enough. Now back where we just extracted that code, let's have an instance of this painting context. And for now, I guess we'll just instantiate it here. There might be a more appropriate place to instantiate it later, and we'll see. Oh, and I said this was sketch painting context, not to be confused with the painting context that you get in a render object. All right, now we've broken a bunch of things, but some of these things that we broke, some of these methods that have a lot of red squigglies, some of them should actually be moved over to painting context as well. For example, start recording and intermediate rasterization and finish recording and rasterize. I think all of those things make sense in the painting context because that's what the painting context exists to do. It exists to record painting operations and rasterize along the way. I don't know which of these should be public versus private yet. We will see as things move forward. Okay. Now let's see, back here in on draw. So we're seeing if there is a published image or not. So if there is a published image, then we draw it to the canvas. Okay, let's make published image public on Painting Context. And now we will say, what do I call it? Just Painting Context.published image, Painting Context.published image. Okay, we've recovered one thing. And let's see what else we've broken here. So over here on the right with the red squigglies, let's take a look at this stuff. Okay, do draw frame. We set a flag that says we're drawing. We refresh or we get rid of the intermediate image because we're going to start again, and then we start recording. Then we do the setup, we do the draw, then we finish recording, and then we make that frame available. I think some of this should be updated, and then some of this should be moved. So on frame available, we can say Painting Context.published image, and that now we've recovered that line. Published image is a public property on our Painting Context because, again, the Painting Context exists to publish rendered images. That's why we have it. But some of these other details should look a little bit different, I think. So intermediate image and start recording, probably start recording itself should get rid of the intermediate image. So let's remove that line from here. Let's come over to Painting Context, and here in start recording, let's first set the intermediate image to null. Clear out any existing painting that we've done. And then we can make start recording and finish recording public. And we also know that do intermediate rasterization should be public as well, because any of these painting methods might need to rasterize to actually turn things into pixels before continuing. Okay, I'm just updating this here. It's also true, I think, that we're going to need a canvas in here that's public, because again, everything that's painting needs access to a canvas. So let's declare that up here. And this will be, we'll just say it's non-null. We'll say it's instantiated late. And let's make that public. All right, and with that change, and if I import byte data, in Painting Context for now, we've removed all the errors. We have a public start recording, do intermediate rasterization, and finish recording. For the moment, I guess we do still have a couple of missing things down here, which is width and height. So we'll deal with that when we get to that information. Rasterize for right now is still a private method. I think that I don't think we're going to need that publicly, but we'll see. Coming back into core, here where we were calling locally the start recording method, we're instead going to call Painting Context.start recording. And then we will say await Painting Context finish recording. All right, now everything seems to at least compile up here near the top. We do have some red stuff down here towards the bottom. So let's see what we need to do here. All right, we're going to have a number of these methods that do things with the canvas. They're all going to, they're going to want to notify the Painting Context that a canvas operation has been applied. I'm trying to think here. I guess for now we can just make that also public on the Painting Context. I mean, in theory, we could have the Painting Context itself implement all of the canvas methods and then internally forward those. Let's leave that as a possibility for the future. And for now, let's just make this flag public. Let's come back to Painting Context. And let's make that property public. Actually, I take that back. Let's undo that, and let's say instead, I don't want anybody to be, I want us in the sketch painting context to be able to reset that back to false. I don't want anybody from the outside to be able to set that to false. So we're going to say void mark has unapplied canvas commands, and then that is going to set the flag to true. And then only we can set it back to false. Which means this is what now needs to be called in all of these methods. Painting context dot mark has unapplied canvas commands. We'll also need to go get rid of this local canvas in a moment, but let's solve the problems that already exist. Replace that method. All right, now in this get method, we need to do an intermediate rasterization. So that's going to say painting context dot do intermediate rasterization. And then we want to grab a source image, which is either the intermediate image or the published image. Let's offer access to both of those for now. We will say image get intermediate image. By using a getter method, we avoid giving other people the ability to change it. And same thing for the published method, published image. So actually, I already made that public, didn't I? So it needs to become private again. Okay, they're not going to let me do that because things are referencing it. So then we're going to say, we're just going to have to do it manually. All right, come back to core, and then we will say painting context dot intermediate image, painting context dot published image. All right, and then down here in get region, we need to say painting context, do intermediate rasterization, and painting context dot intermediate image, painting context dot published image. And we're going to do that again. All right, now there's access to pixels. And so if we look down here, we have public access to pixels as well. And I think we just want to forward that access. Well, so here we're setting pixels. Here we're returning it. So I guess we do. The question is whether we want to allow both reading and writing of pixels. I'm thinking that actually perhaps load pixels belongs in our painting context. And I think it does. I think both of these things belong in the painting context. But these are also public processing methods. So we still need to provide them here. So let me copy these two. We'll come over to the painting context. And let's put the pixels getter with the pixels property. And then load pixels, we will say do intermediate rasterization. And then we will grab the most recent image available and we will put that in the pixels buffer. And now we will come back to the public implementation. Load pixels is just going to directly call painting context dot load pixels. And then this getter here will refer to painting context dot pixels. That's how we're going to get around those problems. Now, when we set a pixel, we will say if pixels, let's see. So this should be nullable. I probably made it non-nullable just so we don't have to check it everywhere, because there's a certain contract there. You need to call load pixels before accessing pixels. And as long as you do that, it's non-null, but technically it's nullable. Let me make it nullable and see if that ruins a bunch of stuff. We'll see if we can make that work. All right. Down here, pixels, take off the underscore. Now set region. We need to take off the underscore. Take off the underscore. Take off the underscore. Although let's see, down here we're setting the pixels, and we shouldn't be doing that. Let's see, what's going on here? We have this combined image. So we're recording to this other canvas, which is, I think, how we get part of an image. Let's see. What is the pixels image? Okay, so this whole thing here is turning the existing pixels buffer into an image. We are drawing the existing pixels. And the problem is these are not on separate lines, so it's difficult to read. So I'm going to add some comments here to prevent turning these into a single line. Okay, so we draw the existing pixels and then we draw the image. I'm not sure that this is necessary. I'm trying to remember if we did things in this order before we had the full implementation of rasterization, and that's why we did it, or if there's something I'm forgetting here about why we need to explicitly combine the existing pixels with the new image. I don't know. Let's come back to that. Solve that last, maybe. All right, I'm just removing underscores here to the pixels reference. Here again, we need to mark that we have unapplied commands. So painting context, mark has unapplied commands. We're going to need to do that here as well for line. Just pasting the same call in all these places that are broken due to the change of the API. Just marking all of these things as having canvas commands that need to be rasterized. All right, and here in save, we're accessing pixels, but pixels might be null. I'll start by saying if pixels is null, throw exception. You must call load pixels before calling save. All right, now we know pixels is non-null, so we'll put in an exclamation point and we're good to go there. Let's see, where else are we broken? Down here again, we need to mark that we have unapplied canvas commands. Okay, so we're down to like 3 issues here. Let's see if, okay, I missed that guy. I missed that one. Okay, so we're back to this one where we're setting pixels, but there's still something else that I know we have to break. And so let's go break and fix that first and before we deal with that pixels problem. And that is our local definition of canvas. We do not want to use a local definition of canvas. We want canvas to be inside of our painting context. And in fact, I think we probably want stroke paint, fill paint, size, and canvas to all exist within our painting context. So let's see if we can make that happen. Let's cut that, come over to painting context, and we already have canvas. Now we have size, fill paint, and stroke paint. I will make these public. And where were we instantiating those? All the way up here in do setup. I think, so the concept of setup and draw makes sense at this sketch level. The painting context, we don't really want to have an understanding of setup versus draw. I think we can maybe move these assignments into the start recording method, I hope. Let's see if that works out for us. Okay. And here we have a reference to canvas, which we now want to be paintingcontext.canvas. Let's scroll down here and find where things are broken again. Here we're setting size. So we want paintingcontext.size. Now in terms of, so the concept of desired width and height versus actual width and height, I think that was originally a consequence of the difference in timing between Flutter's widget building and our actual painting of pixels. I don't know that we need both of those concepts anymore. I'm not going to remove it for right now because we have other things to figure out, but my guess is all we need is this size property and that this desired width and height stuff can go away, I think. All right, now we're going to have a lot of issues around paints and canvases, so we need to come through here and update all of those references. All right. That's the old problem. Let's skip past that and go solve these other issues. In fact, let's see if I can do a replace on this. So every place that we have underscore canvas, we want underscore paintingcontext.canvas. Let's see if we can replace all. Hopefully that worked. And then wherever we have underscore fill paint, we want paintingcontext.fillPaint. Replace all. And every place that we have underscore stroke paint, we want underscore paintingcontext.strokePaint. Replace all. All right, and over here on the right, all that red stuff disappeared. So we're definitely making progress. I think with this last pixels thing, for now I'm going to make pixels readable and writable. However, I will try to come back to this. I'll say to do, see if we can rework the above code so that we don't need to provide write access to pixels. And this will specifically be paintingcontext.pixels. Come over here to painting context, come back up here to pixels, and we will say set pixels byte data. I guess if we're setting it, it should always be non-null. And then pixels equals pixels. Okay, it's going to make me keep the type exactly the same between get and set. And now Flutter's going to complain that I'm not actually doing any work here, and so there's no need for getters and setters. I'm leaving them as getters and setters because I want to eventually get rid of the setter. So I'm going to ignore that complaint from Flutter. Okay, that removes all complaints over here. So it's possible that everything over here works, though it's also possible that it doesn't. We still have a compilation error in painting context down here in rasterize where we have desired width and desired height. I'm going to change this to size.width and size.height, and hopefully that works. And apparently toImage wants integers, so we will round, I guess. Okay, save that. Now this is one reason that we have tests. So if we go to the terminal, unfortunately, if one test blows up, they probably are all going to blow up. So we might be left with a whole bunch of failures. But let's see what happens if we run Flutter test, because I think we compile, and the question is, do things still work the way they're supposed to? All right, sweet. So 54 tests just ran. Most of them were Goldens. You can ignore the print output here. I should go remove that from the tests, but all 54 of our tests passed, which means not only do we compile, but we are still literally painting the same pixels we were before making these changes. So let's take a look through here and see what we've done. We created this class called SketchPaintingContext. Inside, we have a picture recorder, which you can think of as a place where we collect painting operations. Based on that picture recorder, we end up with a canvas. That canvas has a particular size. And so also in theory, I guess size can come before canvas. There's also fill paint and stroke paint. Now those are public because let's say that you're implementing a processing method to draw a rectangle. Obviously you care about the fill and the stroke. These are public details for whomever is using our sketch painting context. You can change these and you can use these however you want. Now canvas here should probably only be exposed as a getter. Let's see if that works okay. So canvas, get canvas. Well, I'm sorry, first let me change this name to make it private. Although it's going to probably complain about that. Let me do that. Canvas, get canvas, return the inner canvas. And then in here, we're going to have some compilation issues right here, underscore canvas. Okay. Now let's go back over here. No new compilation issues that I can see. Good. Because we don't want anybody else ever setting our canvas. We own the canvas. The canvas is really important for what it means to paint things into rasterized pixels. But we do want people to be able to run operations on our canvas, and so we make it public right there. So let's see, here we can say the size of the painting region. And I'm not sure that I can come back and fill in these comments later. The intermediate image. So for those of you who maybe didn't tune in to all of the videos we've done, we are using a hybrid approach in how we paint. We do some things with a canvas, and then we do some things with individual pixels. These two things don't naturally work together. A canvas collects a bunch of operations, and then the GPU actually runs the operations. The pixels aren't manipulated until it gets to the GPU. But some of the things that we do need access to actual pixels. The only way to do both is that when we run a pixel operation, we take our current canvas and we force the GPU to paint it, and then we get the bitmap back, and then we do our pixel operations on top. That is what this intermediate image is for, and I might give it a better name later, but the name says what it is. In the process of painting what we call a published image down here, in the process of reaching a published image, at various times, we might create an intermediate image so that we can combine canvas painting with individual pixel painting. That's why we have it. That's what it does. Pixels is very similar to the intermediate image. It's possible that these things should be combined. Again, something to think about on another day when we continue this process. But pixels the type is different, which is byte data, but the byte data for the pixels essentially comes from the intermediate image. So they aren't really as different as they seem. Now, maybe they should both exist because we want access to an image and we want access to byte data, but it's also possible that maybe they should be one thing called pixels or something like that. Now here we have has unapplied canvas commands. This is the flag that determines when we need to update our intermediate image. If we do some canvas stuff, which means we have unapplied canvas commands, and then we want to do pixel stuff, we need to apply those canvas commands to the intermediate image and then do our pixel stuff. But then finally, at the end of a frame, we produce a frame. We produce a published image, and that's available here under published image. Those are all the pieces of information that we're tracking for every frame that we're painting. Now, this painting context is not counting frames. It's not timing anything. It's just the behavior to start with a fresh frame and then paint that frame and create the final published image. Load pixels does two things. It does an intermediate rasterization, and then it grabs that byte data for pixels, because that's the point of load pixels. When load pixels is done, our contract says that the pixels property has byte data. So that's what we do here. Now let me take this. I'm going to move this actually, because in theory, load pixels would only ever happen maybe right here. I mean, load pixels should never happen before we start recording, right? So I like to keep lifecycle methods kind of in the order that they occur. When we start recording, we first assign a default fill and stroke paint. These are defaults, standard processing defaults. We clear out any intermediate image from the previous frame. We create a new picture recorder. Remember that picture recorder is fundamentally what is making the canvas stuff happen, which is why that recorder is immediately passed into a new instance of canvas. These two things, the recorder and the canvas, kind of work together to make the canvas happen. We already talked about load pixels. We've talked about why we do intermediate rasterization, but here's the implementation. So if we don't have any canvas commands to apply, there's nothing to update. We don't have to worry about it, so we return. Otherwise, we call rasterize, which takes all of our canvas commands, sends them over to the GPU, loads the image back in intermediate image, and then we start recording canvas commands again to go on top. But also, with the new canvas that we create after we start recording, that brand new canvas, we immediately draw the image that we just painted. Remember, I said we make the GPU paint it, and then we load that image back from the GPU, and the first thing we do is stick that image into the new canvas, which is what adds more canvas operations on top. And then we reset our flag for has unapplied canvas commands. Now, at some point, we want to produce an image. We're no longer doing a bunch of intermediate steps. We're saying, okay, this is the end of a frame. So we call finish recording, which calls rasterize again. And this time, the thing that we rasterize is the final image. It's the frame that we want to display to the user, and that's published image. In my mind, this is more or less the core of all painting. If we come back to the thing called core, let's go to, is rect one of these methods? I mean, let's grab any of these. I mean, let's say that I had not already implemented ellipse. Let's say that method didn't exist. And so you came in here and you found a method that was missing. You wanted to implement it. You came to write the ellipse method. This implementation only requires what we've put in the painting context. You have access to the canvas, and you have access to the mark has unapplied canvas commands, and you have access to the fill paint and the stroke paint. We've pulled out a core that applies to pretty much every painting related method in the sketch definition. Now, I told you this was going to get messier before it gets cleaner. Pulling that stuff out, it removed a few variables, and that's great, but we aren't really seeing the benefit yet. The benefit is going to come if we can figure out how to take a bunch of these drawing methods and move them into different files and still give them access to a painting context without implementing all of them inside of the sketch class. That's essentially our goal, because there are quite a few methods in here. It's easy to get lost. I think we're going to call it there for today, though. I might go look at some of these other methods and see if I can move them into painting context, but you get the idea of where we're going here. So in the next video, we'll try to figure out the next area that we can maybe yank out of core or separate these in some way so we can compose them. And again, our primary tools for composition are mix-ins, inheritance, or passing things into constructors to compose things around other things. In fact, the widget tree, when you have a widget inside a widget inside a widget, that's constructor composition. You're calling constructors on all these different widgets, but you're passing widgets into the constructors of other widgets, which are being passed into the constructors of other widgets. So that's one way to get composition. Inheritance is another. Inheritance is typically the worst way. It has lots of constraints. Mix-ins is kind of a healthy middle ground because you can have as many mix-ins as you want, but there are still constraints about what you can do when you use a mix-in. We'll start to see if we can make use of any of those here in the next video as we continue to simplify our core definition. So I will see you then.